Hello and welcome to this exciting video presentation on Chapter 5, Repetition Structures, or what we would normally call loops. The plan in this video is to go through the slides, and I don't normally do this, but I figured that in this particular topic this would be helpful. So I'm going to walk you through the slides as I do examples in small basic, kind of as a launch point for the topic. And so what we're going to talk about, if we follow the chapter structure, this is how they laid things out. They give you an introduction to what is a repetition structure, and then they talk about two different kinds of loops: condition-controlled loops and count-controlled loops. And then they got some examples. They talk about sentinels and nested loops. So we'll get into all of this in the process of the video here. So first of all, what is a repetition structure? Quite simply, it causes a block of statements to execute repeatedly. And if you think about duplicate code, we're always talking about how it's best to avoid duplicating code. And a good example of what not to do in terms of duplicating code here would be a case of supposing that you had to ask the user for a whole set of test scores, and you'd ask them for each score, and then maybe you'd give them an average at the end. Okay, so now if I'm going to do 10 scores, then I'm going to need 10 variables, right? So score 1, a score 2, and so forth. So if I, come in and set this up for score 1, I would have to do this however many times I needed scores for. So if there were 25 students, I'd have to put in, essentially 50 lines of code. And it gets even more fun if I have to enter 100 scores. Now, if I have to enter 100 scores, that's a pretty big job to enter all the data anyway, whether I used a loop or not. But just for the sake of argument, the more repetitions you have to do, the more duplication of code if you don't use a loop. So it gets worse the more times you have to do it. And in this particular case, if I did it this way, then I'd have to calculate an average, which would be score 1 plus score 2, and I just keep going until I hit score 5. And that would be real exciting if I had to do 100 of them. It'd be a huge line of code, and it'd be a real pain in the neck. So this is not a feasible solution, and that's really why, one of the reasons why we have repetition structures is to be able to eliminate all of that. Now, one thing about repetition structures, they work very tightly with arrays, and we haven't talked about arrays yet. So we'll talk about loops, but there's more to the story than what you're going to see here in terms of a lot of practical examples. Like, for instance, here, if we're talking about entering a bunch of test scores, I could make a loop for I equals 1 to 5, and I could put the print, enter the score here, and then instead of input score 1, I would use an array. Now an array is like a bunch of variables glued together. Or if you think of a variable as a box, then you take a stack of boxes and tape them all together. You would have an array. You carry this taped up set of boxes around. That's your array. And each box is called an element. So what I would do is I would make this array, And the way you talk to an array is you address it by its name, and then the square brackets here get you into the array at a certain position. So in this loop, this what we call a for loop, I here is what's called a loop counter. And it's going to execute these two lines of code 5 times. The first time it runs them, I will equal 1. The second time it runs them, I is going to equal 2, and so forth. So when you input score with this I here, it'll start score 1, and then score 2, and score 3, and each time it's going to be asking you for a number, and it's going to put that number into the box in your array until all the boxes are filled up. Well, that's how I would do that. Now, I've gone from a lot of code to 4 lines of code. But you can see here, sometimes we need to bring in like topics like an array, something we haven't covered yet. So just keep in mind that to really know how to use loops properly for all the different ways you're going to want to use them, there are a couple more things we need to talk about, and we'll get to them in the course of the semester. So it allows a programmer to avoid duplicating code. And we obviously have talked about the dangers of doing that. If you have duplication of code, it's a real pain in the neck if you have to change something, because you have to change it many times. And if you miss one of them, now you've got a bug in the code, and it can be very tough to even find stuff like that. So now, when we talk about loops, there are 2 different kinds of loops. And the question is, how do you keep the loop repeating itself? You know, what makes it continue to repeat? Or another way of asking the question, what makes a loop stop? You can run a loop through its course by setting a condition and testing it, or by what's called a counter-controlled loop. A condition-controlled loop, an example of that would be asking the user to enter a number between 1 and 5. The condition may be something like, it's going to be a question, okay? Does the score, or is the score, let's say it that way, is the score less than 1 or greater than 5? If the condition is true, the loop repeats. So if you think about this, I'm going to be asking the user to enter a number inside of my loop. And if they enter a good number, the condition will be false, and the loop will exit. So it'll only have run through the loop 1 time. But if they mess up and enter an invalid number, the condition will be true. It will be less than 1 or greater than 5, in which case the loop will repeat. So basically what it'll do is, if the user enters a bad number, it'll ask again. It'll loop back up and ask again. And it will keep doing that until they get the answer right. So a condition-controlled loop, a good example is user validation, or input validation. So that's a condition, basing whether you continue a loop or not on a condition. Another type of loop we have is called a counter-controlled loop, or the book actually calls it a count-controlled loop. Okay, this would be a condition where you would say the loop runs from 1 to 5, just like the example we looked at a minute ago with the averaging. It's a count-controlled loop. It's going to run the loop 5 times. Now that number may not necessarily always be 5, all right? You may ask the user, how many grades do you want to enter? And you may pull that in a variable, number of grades. So you might be going from 1 to number of grades, whatever that is. So this is a variable, so we don't really know how many times the loop is going to run as we write the code. It's really going to be up to the user. When they run the program and they're asked, how many grades do you want? They're going to type in a number, and it's going to get stored into this variable. The loop is going to run from 1 up to that number of grades. So We don't know the count at design time, but there will be a count. There will be an upper limit, and it will execute X number of times. Whereas with a condition-controlled loop, you don't really have any idea how many times it's going to run. You really just don't know. I mean, we don't know how many times it's going to take for the user to get their act together and enter the right range value. So, but the point though is that both types of loops have value to them. Now, in the case of the condition-controlled loop, there are 3 different kinds that you can build: the while loop, the do while, and the do until. This is true of most all languages, except Small Basic only supports the first one, the while loop. Now you might be thinking, is that a big deal or not? Well, it's not a huge deal. It's nice to have all 3 of them, but the issue at hand with this that we're talking about is really an issue of what's called a pretest loop versus a post-test loop. First of all, we have the post-test loop. This is where a post-test loop, it'll run through the code once, and then at the end it will test the condition and may come back and run again. So a post-test loop guarantees that the loop is going to run at least once. With a pretest loop, the test is done at the beginning. The loop may or may not run at all. So if your test comes at the beginning and the test is false, it won't even go into the loop at all, not even one time. But with a post-test loop, you're guaranteed that it's going to run at least once, and then it may run more times. Now if you think about this, a case for a post-test loop would be something like user input. You know you have to ask at least once. You're never going to have a case where you don't have to ask. You have to ask once or possibly more than once. That's a good candidate for a post-test loop. With a pre-test loop, you may not even want to do this at all. And an example of that might be something where you're asking the user if they want to do something that's optional. And you put the question at the beginning, and they say yes or no at the start. And if they say, yes, I want to do this, then we go into the loop, and we do whatever was supposed to be done, and then we come back up and ask them again, do you want to do this again? And they, so at the very beginning we ask the question, and does it if they keep answering yes. So in terms of user input, user can choose whether to do or not, and then whether to repeat. So they can choose whether to do it at all, or they can say, yes, I want to do it, and then they can continue to repeat doing it. Now, both have value, essentially. In most languages, you have access to all 3 types of loops. The first one is a pretest loop. The second 2 are post-test. How do I know that? Because they start with the word do. The while is at the end. So it's going to do, and then the hyphen. If you look at that hyphen, picture that being the code you would repeat. You're going to do a task while a condition is true, or you're going to do a task while a condition is false. And depending on your logic, you can do either. Now, you don't really need the do until loop, because all you have to do is put your condition in negative terms instead of positive terms. For instance, do while loop is less than 5 is equivalent to saying do until loop is greater than or equal to 5. So you really don't need a do until. Ideally, you really want to have these two loops structures. And again, almost every language I've ever worked with does have both, except Small Basic. It only has the first one. The second one we can do, we just have to wave a little magic wand around and then it works, which we'll get to later. Now, in terms of the flowcharts, which the book talks about, they will put a loop together like this. The condition is a diamond shape, and then the statements are rectangles. So it'll ask a question, and if it's true, it'll do something, and then come back up and ask the question again. This is a pretest loop because it asks the question first, then it does the thing, and comes back up. Here's an example of user input. Now, if you're going to use a pretest loop, you don't have to use a post test. You can do everything with a pretest loop. For instance, here with user input, we said earlier that you really like to have a post test loop for user input. But what you can do is something like this. You can create the condition and set it true first, so that when you ask the first time, it will be true. So that it will always be true initially and go into the loop and run it. So here, if I declare a string called keep going and I set it equal to y, I come into my loop and it tests it. Is keep going y? Yes, it is, because I just set it. It's going to go in, do the stuff, ask inside of here, do you want to calculate another? And they say yes or no, it comes back up and asks the question again. So you're essentially tricking the loop test so that the first time in isn't really set by the user, it's set by the program to force it to go in one time at least. So this is an example of how you would get around the fact that there's no post-test loop by doing what we call, this is a priming read, is what this is called. A priming read sets the loop up to pass the first time. So the moral of all of that is that even with Small Basic, a while loop is sufficient for everything. I'll show you all the variations of all of this when we get to looking at the examples. Here's a post-test loop where you do all the work first, then you ask the question, and if it's true, you come back up and repeat the steps. Notice the syntax. You have a do here, then a bunch of statements, and then a while at the end with a condition. The while loop structure has a while condition at the beginning, then your statements, and then an end while, and it loops back up. Here is a do until loop where it just simply negates the condition from true to false. Now, a counter-controlled loop is, again, where you have a certain number of times, and this is best expressed with something called a for loop. Small Basic has for loops. The way you set them up is you say for, and then you set up some sort of a counter variable and set it equal to a starting value, and it runs through to an ending value. You put your statements inside, and it will run however many times you specify. And here's an example of a flowchart for a for loop. It's a little bit difficult to see that this is a for loop, but if you look here, you come in setting the counter to 1, you check to see if it's less than or equal to 5. If it is, then you run the code, and every time you go through the loop, you bump the counter up by 1. So it started at 1, runs through, becomes a 2, comes back up, asks again, 2 is still less than or equal to 5, runs through it, counter goes to 3, 3 is still less than or equal to 5, and so forth, until it hits 6. Now when it hits 6, it will have run through the loop 5 times already. 6 is no longer less than or equal to 5, so it falls out of the loop and moves on. And so the net result is that it executes the code 5 times. Now this 5 here is called a Sentinel. It is a special value that marks the end of a list of values or a stopping point for a loop. So run something X number of times. X is the Sentinel. And in the example that we sort of cobbled together with pseudocode, number of grades would be a Sentinel. So that's just a term you want to keep in mind. And then finally, we can nest loops. In other words, we can put loops inside of loops. And I'll show you an example of this in the Small Basic code, which we'll do in the next part of the video. But you can see here that looping can, just like with if statements, you can put them inside of each other. So that's sort of the theory behind loops. So what we're going to do next is I'm going to turn this part of the video off and make a second part. And in the second part, I will get into Small Basic and show you some of this using some examples. So we'll see you in the second part, and thanks for watching.